Welcome to our lesson on handling exceptions like a pro. In programming, errors are inevitable, but crashing is optional. Exception handling is the practice of catching unexpected errors during execution, allowing your program to recover gracefully instead of abruptly shutting down. Think of exception handling as a safety net for your code. If your script hits a snag, like a missing file or bad user input, it's like a tightrope walker losing their balance. Without a net, the program crashes to the ground. With one, your code is safely caught, allowing you to handle the issue and carry on. Here is the foundation of error handling. We wrap the risky code inside a try block. If an error occurs, Python stops executing that block and immediately jumps to the except block. Here, we catch a division by zero, preventing the program from throwing a messy traceback error. It is a best practice to catch specific exceptions rather than broad ones. By naming the error like zero division error or file not found error, you ensure you are only handling what you expect. This keeps your error messages accurate and prevents you from accidentally hiding bugs that you didn't intend to catch. The else block is a handy tool that runs only if the code in the try block succeeds without any errors. Think of it as a way to separate your risky operations from the logic that depends on those operations working perfectly. It keeps your try blocks clean and readable. The finally block is your cleanup crew. Regardless of whether an error occurred or the code finished perfectly, the code inside finally will always execute. This is perfect for closing network connections or file streams that must be shut down to prevent memory leaks. Here is a pro tip: never use a naked except block, which is just the word except followed by a colon. This catches everything, including system exits, making it nearly impossible to debug real issues. Always specify the exact error type, like value error or type error, to keep your code predictable. You don't need multiple blocks for every single error. You can group them together by wrapping the error names in parentheses right after the except keyword. In this example, one line catches both a bad string input and a division by zero, keeping your code clean and concise. Let's look at a practical scenario. When reading from a file, we want to ensure it closes even if an error occurs during reading. By wrapping the logic in a try block and the closing command in a finally block, we guarantee the file connection is cleaned up every single time. Time for a quick check. Which of these blocks is guaranteed to execute regardless of whether an exception was raised during your code's execution? If you guessed finally, you are absolutely right. It is the designated spot for final cleanup operations. To wrap up, remember these 3 keys to exception mastery. Use the try block to isolate risky code. Use except to handle specific errors gracefully, and always rely on finally for cleanup tasks like closing files. Applying these consistently will make your Python applications truly professional and resilient.